Welcome to my 21st tutoring session in A-level chemistry. In this video, I'll give some useful tips for predicting the group element based on their ionization energy values in the table. Please take a moment to watch my previous video on the topic periodic trends in ionization, as the video will provide you with better understanding of this video content. Link to the video is given in the description, so please do watch the video. Now here are some useful tips for predicting the group element based on their ionization energy values in the table and electron structures. Before I get on with the useful tips for predicting the group element, I'd like to brief about the ionization energy. What is ionization energy? It is the amount of energy required to remove an electron from an isolated atom or ion in the gaseous state. Ionization energy is also a measure of the strength of the attraction between the positively charged protons in the nucleus and the negatively charged electrons in their respective shells or energy levels. Now I have selected three elements from three different groups in the periodic table. Lithium belongs to group 1, magnesium belongs to group 2, and aluminium belongs to group 3 in the periodic table. Now in order to predict the group element, I will use the ionization energy values in the table and examine their electron structures simultaneously. I have color coded the core electrons and the valence electrons. The valence electrons are highlighted in blue, while the core electrons are highlighted in red. Let me start with the lithium element. Lithium belongs to group 1, so it has only one valence electron in the outermost shell. So lithium undergoes first ionization, losing its only valence electron in the outermost shell, and 520 kilojoules per mole of energy is required to remove the valence electron. Now let us try remove the core electron. Now the lithium ion undergoes second ionization, losing its core electron in the first shell of lithium atom, and you can see that enormous amount of energy is required to remove the core electron. Around 7,300 kilojoules per mole of energy is required. So you can see 14 times jump in the ionization energy value. So only 520 kilojoules per mole is required for removing the valence electron. Coming to the core electron removal, it needs nearly 7,300 kilojoules per mole of energy. So there is a 14 times jump in the energy required. So this clearly shows that it is easier to remove the valence electrons than the core electrons. What is the reason? The reason being the valence electrons are far away from the nucleus and experience a weaker attractive force towards the positively charged protons, while the core electrons, they are very close to the nucleus and experience a very strong attractive force towards the positively charged protons. And therefore, the energy required is more in case of removal of core electrons. Now moving on to magnesium. Magnesium has 12 protons in its nucleus. It has a total of 10 core electrons, 2 in the first shell and 8 in the second shell. And in the outermost shell, you find 2 valence electrons. Now magnesium undergoes first ionization, losing its first valence electron, and 740 kilojoules per mole of energy is required to remove. Now when the magnesium ion, that is Mg plus ion, when it undergoes ionization, second ionization, the second valence electron is removed or lost, and in the process 1450 kilojoules per mole of energy is taken or used. Now when the core electron is removed, you can see that a drastic jump in the ionization energy value. Around 7735 kilojoules per mole of energy is required. So magnesium has two valence electrons, and during the removal of two valence electrons, there is increase in the ionization energy values, but it is not, the difference is not that big. But when the core electron is removed from the new shell, you can see a drastic jump in the ionization energy values. So you can see nearly 5 times jump in the ionization energy values. Now coming to the aluminium, it has 13 protons in its nucleus. It has a total of 10 core electrons, 2 core electrons in the first shell, 8 core electrons in the second shell, and a total of 3 valence electrons in the outermost valence shell. Now when aluminium undergoes ionization, it loses its first valence electron, and 580 kilojoules per mole of energy is required. When it undergoes the second ionization, that is when Mg plus. So magnesium undergoes ionization to form magnesium ion, that is Mg plus, and Mg plus ion in turn undergoes second ionization, and for this 1820 kilojoules per mole of energy is required. And the third valence electron is removed when the Mg2 plus ion undergoes third ionization, and 2745 kilojoules per mole of energy is required. Now when the core electron is removed, you can see a drastic jump in the ionization energy. So nearly 11,580 kilojoules per mole of energy is required. So in a nutshell, the valence electrons are the ones that can be easily removed as compared to the core electrons, because the valence electrons are far away from the influence of the protons Coulombic force, while the core electrons, since they are closer to the nucleus, very difficult to remove, and it requires more energy to remove them during the ionization process. So what is the takeaway from this discussion? So there is no jump in the ionization energy when the valence electrons are removed, because the valence electrons are further away from the nucleus and loosely held, and therefore less energy is required to remove the valence electrons. While in case of core electrons, there is a jump in the ionization energy after the removal of core electron, because the core electrons are closer to the nucleus and tightly held because of the electrostatic force of attraction between the positively charged protons and the negatively charged electrons that are closer to the nucleus. And therefore, more energy is required to remove the core electrons. So here, so how to identify or predict the group element? You should see where actually is the jump in the ionization energy. So in case of lithium, there is jump after first ionization, and therefore it belongs to group 1 with 1 valence electron. Magnesium, you see a jump after 2 ionization, therefore it belongs to group 2 with 2 valence electrons. In case of aluminium, you see a jump after 3 ionization, therefore it belongs to group 3 with 3 valence electrons. Time for practice question. Now you have to identify the groups of the elements X and Y in the periodic table. So you are given with 6 successive ionization energies for elements X and Y, and you have to identify the group to which elements X and Y belong to based on their ionization energy values given in this table. So you have to see where actually the jump is. So in case of element X, you can see that after 2 ionizations, you can see a jump in the third ionization. So nearly there is 4 times jump in the ionization energy value. and therefore the element X belongs to group 2, because group 2 element will have 2 valence electrons. So there will be no jump when the 2 valence electrons are removed, but there will be jump when the third ionization energy takes place. And similarly for element Y, you can see that there is a 3 times jump between the 5th and the 6th ionization, and therefore since you see the jump in the 6th ionization, it belongs to group 5. So in element X, there is jump after 2 valence electrons are removed, and therefore look for the group with 2 valence electrons. So which is the group with 2 valence electrons? It is group 2. Therefore element X belongs to group 2 in a periodic table. And what about element Y? So based on their ionization energy values given in the table, so there's a jump after 5 valence electrons, that is after removal of 5 valence electrons, and therefore look for the group in the periodic table with 5 valence electrons. And obviously the element Y is a group 5 element. So group 5 element will be having 5 valence electrons. Don't forget to subscribe my channel, share and like my videos. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.